Here's an explanation for the answer to final exam question number 45 in Electronics Demystified, 2nd edition. Please see page 426 if you have the printed book. We're talking about the ionosphere here, the upper atmosphere of the Earth, which has 4 different layers that occur at different times of the day, different times of the year, and different frequencies of radio wave propagation. The D layer, the E layer, the F1 layer, and the F2 layer. They exist at the approximate altitudes shown here. The D layer, 30 miles or 50 kilometers. The E layer, 50 miles or 80 kilometers. The F1 layer, 125 miles or 200 kilometers. The F2 layer, the highest, at about 180 miles or 300 kilometers, but these values can vary somewhat, and these ionized atom layers tend to be kind of fuzzy. They're not well-defined strata. They're almost like very high clouds that you just can't see. But the question is asking us which of these layers offers no advantage for high-frequency, long-distance radio communication and, in fact, can have a detrimental effect. And the answer is D. It's the D layer, the lowest layer, which generally exists only during the daytime and tends to vanish at night. This layer absorbs radio waves at some frequencies. So, for example, if you can recall, if you're old enough to remember the standard AM broadcast band, if you'll remember that, about 535 to 1605 kilohertz, that's the old AM broadcast band. If you remember that, and remember listening to stations in the daytime versus stations at night, there was a very dramatic difference. You would hear stations from far away at night, but during the daytime you couldn't hear them. The reason you couldn't hear them during the daytime was that this D layer became active and absorbed radio waves that were trying to propagate by means of what they call the sky wave. The sky wave, you might have a transmitter located, say, right about here. Radio waves can bounce off of these upper layers, or actually they refract and come down at some distant point like that. That happens at night on the standard AM broadcast band. But during the daytime, when a radio wave tries to find its way up, this D layer stops it, foils the attempt, and so long-distance propagation becomes impossible. So the correct answer, once again, to this question is D. The D layer offers no advantage at all for high-frequency radio wave propagation. By high frequency, we mean roughly the AM broadcast band up to about 30 megahertz. It offers no advantage and, in fact, can cause problems. So again, the correct answer to this question is D.